Welcome to another edition of Building Tech Talk. And today we're talking CO2, and we're talking with Andrew McMurray and Matt Henderson of Arkams Technologies. Did I get all that correct?
Yep. Good so far.
Nice. Excellent. What do you guys do?
We do carbon capture. Quick background, I suppose. Arkams Technologies was founded in late 2019 with Andrew and I looking to bring simple solutions to the oil and gas industry to help improve the carbon footprint of the industry. Do you have anything to add there?
Yeah, no. We started Occams in 2019 with the hopes to decarbonize the oil and gas industry. Both of our backgrounds are in oil and gas. I started my career at Shell. As you can see, they're slowly migrating out of the upstream business into more of a downstream, more carbon capture business. Had the chance to work as an environmentalist on the inside and actually hydraulic fracturing. And now trying to pivot my career into, helping decarbonize this commodity that we have so abundant in our natural gas and natural reservoirs in Canada and the US, and turn it into something that's more powerful and useful for a growing society.
Excellent. And I know that's something that our resident experts here are always interested in, ways to decarbonize and reduce footprint. So introducing Scott Jenkins, CEO, ZS2 Technologies, and Dr. Doug Brown, CTO at ZS2 Technologies. So gentlemen, I think this is something that definitely has been on your radars as far as looking at what Arkams Technologies is doing in order to decarbonize oil and gas, but also how that can apply to the building industry and where we're going as far as a decarbonization. So Doug, maybe starting with you a little bit, kind of what piqued your interest about what Arkams is doing right now?
Yeah, so I'm very interested in fuel cells and the role they may play in decarbonizing our grids. And so hearing about your guys' company, I was excited to see maybe what the nuances are between what I think has become mainstream on the hydrogen economy and how maybe a fuel cell has a role to play there. And on, what are the challenges that you guys are facing in this sort of commercialization process?
So in terms of the technologies that we're bringing to the oil and gas industry, so fuel cells, they're an existing kind of legacy technology in just power anyways on their own. And we're basically looking at introducing technologies that exist elsewhere in the world, like carbon capture, water purification and whatnot, and bring them into the industry. So in regards to what you're talking about with fuel cells, what we're trying to do is attack on carbon capture on the back end of fuel cell power generation. Fuel cells inherently have the ability to be very small and mobile and produce quite a bit of power. They're very efficient. But they're not capturing the carbon, just like a power plant. Most power plants right now aren't capturing carbon. So, in the lab, that's what we're trying to do is build that technology to capture CO2 on the back end of a fuel cell and then mobilize both of those devices together into the industry. On top of that, there's also the fuel for fuel cells, which is hydrogen. And Alberta is doing a fantastic job of trying to pivot, the oil and gas market towards a hydrogen economy. Which complements the fuel cell effort as well, because hydrogen is the primary fuel for fuel cells. Do you have some more?
Yeah, when we talk about carbon capture, really the fundamentals of business when it started was how do we take a hydrocarbon molecule and turn it into a green electron, right? Like following that whole process flow from the wellhead to then emitting some sort of carbon dioxide in the form of energy generation was something we started looking at. So everything from fuel cells to hydrogen production to carbon capture and then water treatment are all within the wheelhouse when we look at turning that hydrocarbon molecule into an electron and doing it in a more environmentally friendly way.
A greener electron at the end of the day.
Yeah. So would it be fair to say what really interests me with Occams and all the development they're doing, and there's obviously some applicability to some of the work Doug's and his team are doing, is, even based on your background, you're working within obviously one of Canada's largest industries, one of the biggest contributors to our economy, an industry that's not going away, but needs to shift. Mm-hmm. And so you're helping or the goal is to accelerate that shift to a greener, more sustainable, output, if you will.
Yeah, absolutely. So, the the carbon intensity of the oil and gas market is often associated with the carbon intensity of the fuel they produce. But the oil and gas market itself doesn't emit that fuel, that CO2. It's all the consumers of the hydrocarbons that emit that CO2. However, there's trucks and there's flare gases, flare stacks, there's venting issues that go on that the industry is responsible for those emissions. And we can capture those with relative ease without, when I say we, I mean the industry itself can capture those relatively easily. But the hydrocarbon itself, like let's just talk about natural gas and natural gas power plants. Why aren't we capturing those emissions, and why don't we send that fuel through a fuel cell and capture the emissions there, or convert it to hydrogen? Well, convert it to hydrogen, send it through a fuel cell, and capture the emissions in that way.
Yeah. So really, like if you think about a natural gas power plant, Doug's going to make fun of me. He does make fun of me a lot, so it's actually okay, both on camera, off camera. So if we think about the emissions as being this untapped energy source, you're thinking about it like, wait a sec, like that's tremendous economic value as well. If the technologies that you're developing or already have developed, if we can take that and then bring it to scale, and obviously I've been privy to, I've seen the pilot models and all of your testing, and it's fascinating, and your successes to date, and then take that, I just see this huge economic benefit of, if I think about an engine, I think about like a supercharger or something, taking emissions off and then spinning that back in, or a turbocharger, right? That's kind of like, from a layman's, there's a tremendous value to the whole chain there.
Yeah, I think some comments on that would be that the industry is kind of proven it on large scale. We've been able to do the Shell sequestration and utilization project they have up at the Scotford refinery in Fort Saskatchewan in Alberta, which is one of the most successful carbon sequestration projects we have in Canada. But trying to take that into a smaller scale to make it more acceptable for some of the smaller businesses, allowing them to pivot, has been a challenge. It's very hard to scale some of these things down. And when you look at it, you need a very integrated approach. You can't just have a super small CO2 capture unit and then have a very small injection well. Like, in order for these to become more economic,
They have to be at scale.
Values of scale, but looking at it in a smaller fashion, there's opportunities there, and that's what I think we're trying to tackle, specifically in the fuel cell component. Like, fuel cells are very expensive to install per kilowatt of electricity that's produced, and you need a very refined fuel to go in those fuel cells in order for them not to damage. So when we talk about different qualities of hydrogen, you need a very high quality of hydrogen to go into existing PEM fuel cells. So right, that's correct, right? Versus if you're trying to steam methane reform hydrogen and you have some carryover of other methanes or uncombusted or unconverted molecules, those can damage some of that equipment. So when you look at it, it's not just like hey, just put this in the field. We can then produce 10 tons of hydrogen a day, and then that's going to be open to such a wide market. You really have to understand who that end buyer is going to be and where that fuel source is coming from, and have that integrated approach across most of the carbon capture and sequestration value chain in order to get to a point where we think that this is going to be more attractive to other people. And as soon as we start to see some scale come to this from the industry, from support by the government, or from more projects like the ones that we're working on, I think the adoption is going to be easier. But that first step in the right direction, is still struggling, I think.
Yeah, on that note, how are you guys seeing this technology play out in sort of the minds and the hearts of people, given the fact that, there's a global movement away from oil and gas, and, it's not often necessarily founded in solid science. It's more of this social responsibility. But if you do answer the CO2 question around burning fossil fuels, then there shouldn't be a hesitancy to broad adoption of a technology like this. But have you seen pushback just on the fact that, hey, you're promoting the use of fossil fuels?
I know I've been talking a lot, but I want to talk again. So I just got back from the Philippines. I was over in the Philippines for a month, over 40 days, working on a geothermal power plant over there. And when we think about geothermal in our industry, we think of green energy sources, this like green base load. But it was a disaster. I mean, there was junk everywhere. It wasn't as clean. The perspective that we have going up into northern Alberta, watching the oil sands operations or unconventional operations, like we do a state-of-the-art type of hydrocarbon recovery here in Canada. I can't say the same thing about the US, but here we have a very high standard. If you were going to look at oil and gas exploration anywhere in the world and you wanted to take the best environmental policies, you would copy paste what Canada has done. And it's too bad that we're not able to do that, focus on reducing the emissions of hydrocarbon production. Because, my experience I just had in the Philippines, where they have some of the best geothermal resources in the world. We're cross-applying oil and gas technology now to this green science. But it's still not to the same sort of standards, the environmental standards that I would expect, given the perception of what green energy looks like in our business, right? So I think there's a big shift over to those things. But if we can do what we're currently doing in the oil and gas industry better, which I think is what Matt and I are really trying to do, there's just that much more competitive advantage that puts Canada on the forefront of this green energy transition, utilizing our natural resources again.
Yeah, and just I think it's really a really important point to say that Alberta has one of the most closely regulated and watched oil and gas and hydrocarbon recovery industries in the world, and that drives the reputation that we have globally, at least within the oil and gas industry. That if you want to do something really well in it, what are they doing in Canada? Let's see what we can adopt there, and that's what Andrew and I. That's the edge of the envelope Andrew and I are trying to push even further. We want to reduce our CO2 emissions within the industry even further. And when oil comes out of the ground, if we can quickly convert that to CO2 and hydrogen, then we've got our hydrogen fuel that came from the oil and gas industry. So these people are still employed and the industry is still alive and active, but we're able to capture the carbon right away, oftentimes at lower energy cost, OPEX cost at least. And that's at the cutting edge. It improves things. It teaches the world, like, look, this industry is needed to accomplish the task of reducing emissions that we need to accomplish globally. And, it doesn't need to be demonized.
So one thing though, and maybe this is a bit of a segue, is you said, that you guys are really at the leading edge of the envelope. So, ahead of us, in all of our prep for the podcast, we were chatting a little bit about your company's name and Occam's Razor. So maybe that would actually be because, talking about the Razor's Edge or Occam's Razor. So just for, for the 12 people who are going to view this, which is becoming part of my running joke, maybe you could give a little background on the company's name and where that came from and the premise.
So a lot of green tech startups, take some fantastic science out of a university somewhere and start, they get a whole bunch of funding and they start a startup and it's very science intensive and whatnot. And Andrew and I just thought, there is real technology that exists already. Let's go find it and bring it to the industry. We want simple solutions for complex problems. And that's the basis of Occam's Razor, which is the scientific premise that the simplest solutions to a complex problem is usually the correct one. So
that's what we're trying to do. I mean, we're trying to make carbon capture accessible to anyone on a small scale or a large scale. The technology we're working on here in the fishbowl is going to have the ability to scale depending on if it's a small application or a large application. We're just going to have these modular units like Lego blocks that we can go and say, hey, this is your application. This is what size you need. This is the type of absorbance you need. And this is the technology that's going to get you there. Versus some of the larger scale, which just allows us to, expand modularly and get there. I think there's a lot of modular type of technology in your business as well, right? I think this is a future where it's going. If we can simplify this process, make it easier for anyone to get access to it, I think that there's going to be scale there, independent of, modular and scale being kind of antonyms.
And there's so much focus, it seems, on reduction. Reduction on CO2, cutting back, taxing, regulations around how much you can emit. Have you guys seen any interest in what you're doing from a regulatory standpoint, saying, or even from an investment standpoint, from governments, from regulatory agencies, saying, this is the other part of the equation, and it sounds like there's some value in what you guys are doing. There's a, like you said, a value chain. So there's a business model here, but we never hear about it. We never hear about carbon capture being part of the solution on the same scale that we hear about, drive your car less or turn on your heat in the winter and whatever it is. Why don't we hear more about what you guys are trying to accomplish?
Small scale carbon capture is very difficult. Like there's some CCS plants around Alberta, like Shell and whatnot. I know there's a carbon capture facility in Saskatchewan, and they're capturing megatons per year, like millions. It's great that they're doing it and they're putting it underground, and that's fantastic. One of the things that's making it possible for them to do that is the price on carbon, which is important. If people can recover some of the cost by selling a credit, that reduces the cost. And what we're trying to do is shrink that technology down. So, for instance, small users that have 100 tons per day being emitted from a facility up north, where there's only 5 people working or something like that. Those guys have some incentive to capture that CO2 and convey it to the Alberta Carbon Trunk Line.
Yeah, I think that there are a lot of people out there doing this. Like you've seen a lot of top talent in the oil and gas industry switch over to looking at CCUS opportunities. The AER right now has a big push at people trying to look at pore throat injection and where we can actually store this carbon for longer term periods of time, right? When you think about carbon storage, you can't just take a single well in a field and think that you have integrity of that one well and say, okay, this is great. You need to look at every single well that penetrates that formation in order to actually have some confidence that carbon is going to be sequestered down there. The second thing is there's a huge opportunity for EOR, especially in our unconventionals, which I think is undervalued. I mean, there's still a lot of great stuff happening in Weyburn with this carbon trunk line. There's a lot of mature assets that have historically had CO2 injection that have improved the hydrocarbon recovery on the back end, because CO2 is a miscible fluid in a hydrocarbon fluid. So it will decrease the viscosity and enhance your ability to improve the recovery factors for those wells. However, it's not down there forever, right? There still needs to be management of annular flows, and the technology side of our business. If we don't have good cement bond logs or good cement jobs and there's surface casing vent flows, it becomes an issue. So it's much harder than just saying, hey, let's just inject it here and it'll hopefully be stored forever. I mean, pore throat space and subsurface evaluation, which takes a lot of experience from the oil and gas industry, is now being used in this green carbon utilization network, which I think is only going to get more and more light shed on it. You can see companies like Advantage Energy, who's a hydrocarbon producer in northern Alberta and BC, switching to their new entropy business. So this is an internal company to Advantage. My belief, maybe you should do your own research, but
give it the plug.
My understanding is that they're focused on carbon capture, and the investor sentiment around that has been fantastic for their stock. I mean, you should see when they started press releasing this information to where it is now. I mean, I really think that the investors out there in the industries are ready for these type of pivots, and you can see that in example one with Advantage.
I was just going to say, in terms of both of your experience in the energy industry, and obviously we've chatted a lot. What I think is amazing what they're doing is, Occam's razor is taking existing technologies, actually bringing it to a scale so it can be more widely deployed, but using existing resources from your experience, from your connections in what is one of Western Canada's or Canada's largest industries.
Yeah.
And obviously we also see from an investment standpoint, strategic partners, there's a tremendous interest in, companies that have true commercialization potential for sustainable technologies. Obviously that's, at the core for ZS2, that's everything we do. But there has to be a business case for it. It's not just, a hope or a dream.
Yeah. Well, for a lot of these guys, the business case comes from ESG push from their investors, people saying, if we're going to give you money for next year's round of drilling or something like that, we want to see that you guys are actively trying to reduce your emissions in some capacity, or not even just emissions, footprint. less water use, or more recycled water use, that sort of thing. Being good neighbors, it's important. The operators are getting it from their investors, but also the operators themselves are motivated to do it as well. These are young and intelligent people that are environmentally motivated, and they all have families, and they all believe that oil and gas has an opportunity
To play a major role.
substantially.
You got it.
Yeah, I also think that it's kind of overwhelming as an engineer, an operations engineer, let's say at an oil and gas company, to say, hey, we want to make this pivot, and there's all these different tools and technologies out there, and what we're trying to do is synthesize those into like a package that says this is probably your highest value add component that will make the biggest impact to this business, and then build out different types of programs in order to slowly tackle the lower and lower hanging fruit, or the higher and higher hanging fruit. So tackle the low hanging fruit first, then go to the high hanging fruit. And I think it's a little bit overwhelming because there's a lot of different solutions out there. A lot of stuff is not proven. Some stuff is proven. So, where do you want to cut your teeth on an energy transition type of technology in some of these oil and gas companies? And I think just understanding from our backgrounds how a lot of these companies operate, what the different initiatives are and what the value impact could be in their businesses, is what we can bring to the table for a lot of our clients.
Yeah, one company that's doing really well recently is Westgen, where they've taken, they've started implementing solar solutions to reduce solar solutions to power compressed air and switch valves over to compressed air drive,
Right.
as opposed to the natural gas from the well drive, which would lead to an emission.
And their business is packaging this together so it's tight and neat. It takes instrument air and removes a high bleed source from your well site. So a lot of these well sites use natural gas pressure to actuate valves and operate their facilities. So what Westgen has done is they've added an air compressor, so they have engineered air on location that operates these valves, removes the high bleed sources, and does it in a very efficient manner. And they've been, almost globally recognized right now as one of these pivotal energy transition technologies that has just a packaged program that's nothing really new, not in a negative sense, but something that's very proven, that's been compiled together, that's super easy to operate.
Yeah, very simple solution.
Yeah.
Perfect.
Well, what from our perspective here, and one of the reasons we were excited to have you on the podcast was, the technologies that you guys are bringing together, packaging, working on for this large industry. There's parallels to what Doug and his team and growing team are working on for the cement industries and the built environment. Much like the energy patch in Western Canada is a huge industry, so is construction and materials. So I think what's kind of really cool is to have this made in Alberta company really advancing all of these technologies, similar to ZS2, which is kind of neat. So, I applaud what you guys are working on.
Yeah, no, it's really fun working with Doug in the lab here. He's helped me troubleshoot the rig we've got operating, but he's always asking me about, like, if you find a well with a lot of magnesium in it, let us know. We need magnesium. So yeah, we're aligned with Lodic Technologies out of Edmonton as well, that does water purification. And that's something we're just forwarding to them. Like, you find water with magnesium in it, and just give us a bucket, and
we'll take all the magnesium you got.
Yeah.
Just to close off this episode a little bit, just kind of looking forward, and Doug, maybe you can weigh in on this a little bit too. Like, do you guys see this as being something that, bringing it back to the built environment, where you'd be able to commercialize something where when somebody goes to do a development, whether it's a housing development, whether it's a commercial development, is it possible in the future that this value chain will be created and then that development would have a carbon capture just as part of building, like any other piece of infrastructure, in order to address some of these carbon issues? Is that something that you think the industry will be looking at in the future?
I think from my point of view, it's exciting because we have in our lab, the Matt and I share a carbon capture unit that takes up about 12 cubic feet. And if you can make something that size that's commercialable and actually somewhat economic, which it's looking fairly promising, to be honest. I think that opens up a huge opportunity for carbon capture that hasn't even been explored because of what Andrew said. That these things generally do not work at that scale because of the economics.
Yeah. So further to that is, and getting back to the fuel cells, which are, fundamentally pretty small power. When I say small, they're like small devices that produce a certain amount of power. They're perfect for decentralized power, and this is where you put a small fuel cell on a in an oil and gas facility somewhere. You can also power a small community, 10 houses or 100 houses with a certain size fuel cell facility, and tack on carbon capture right there, which right now is uneconomical. If you were to take the large scale amine carbon capture facilities, shrink them down to 100 tons a day facility, uneconomical. But with some, when you match it with fuel cell power and that you've got that high concentration CO2, you can shrink it down pretty small, which is neat.
So Matt, if I was to summarize, and obviously the work we're doing with Matt and Andrew and their team, here at our lab, at our tech center, but also what we've learned is, what's interesting is, in my background in building companies and in the construction industry, and back in the day with Pure Technologies or with Dirt Environmental Solutions, and scaling them up, it was always taking what we had and scaling it for big, and getting it to scale, because that's where the economics existed. What's fascinating about Occams and what these guys are doing is, the whole business model is taking something which has been proven at massive scale, but is very difficult to do, where you can then roll it out actually to the masses or much smaller. And so it's fascinating. They're going the reverse way, and that's where the opportunity is. And you guys, that's why you've called the company what you have. It's Arkams Technologies.
Well, we're looking forward to
Brilliant.
checking in with you guys again very soon and seeing the progress you're making and what we can look forward to in the future. So thank you very much for joining us. And thanks everyone for listening to Building Tech Talk. And be sure to subscribe on YouTube and ring the bell, get your notifications, as well as subscribing on Apple Podcasts and Spotify. And we'll see you next time.
Thank you.
Thank you.